Okay class, this is Introduction to Probability from our textbook Business Statistics, a Decision Making Approach, 6th edition. These are the goals of the chapter. After completing this chapter, you should be able to explain 3 approaches to assessing probabilities. Second, apply common rules of probability. And third, use the Bayes theorem for conditional probabilities. This chapter is quite long, and there are, for the common rules of probability, there are 10 of them. In this part 1, we can discuss only the first 4 of the common rules. Rules 6 to 10 will have to wait for part B of the chapter. So here are important terms in this chapter. Probability. What is probability? Probability is the chance that a particular event will occur. The probability value will be in the range of 0 to 1. 0 to 1 only. No negative, no more than 1. This means that a value of 0, that means the event will not occur, will not happen. And a probability of 1 means the event will certainly occur, it will happen. And anything between 0 and 1 reflects the uncertainty of the event occurring. Walay kasiguruan. But there are probabilities, and probabilities are usually expressed in percentage. That was probability. Now experiment. For this chapter, this discussion, experiment is a process that produces a single outcome whose result cannot be predicted with certainty. The experiment maman siya. We are not sure what the outcome would be. Another term is sample space. You should be familiar by now with the term sample, but this one is sample space. It is the collection of all outcomes that can result from a selection, a decision, or experiment. And another term is event. In common use of this term event, we can say that there's a wedding. A wedding is an event. A party is an event. But here, an event is a collection of experimental outcomes. So, experimental outcomes, a collection of experimental outcomes. That's what we mean here by event. Of course, we will expand this definition a bit later. Now, let's talk more about the sample space. Sample space. The sample space is the collection of all possible outcomes. Like in our previous discussion, chapter 2, I think it was, or 3, population is the collection of all possible values. Here, the sample space is the collection of all possible outcomes. Example of this would be all 6 faces of a die, or 6 sides of a dice, what we call sa Bisaya dice. In English, they call it a die, singular. Dice would be plural. Where there's 1 here, 2 here, 3, 4, 5, and 6. These are all in different sides of a cube. A cube, which they use in gambling, and they cast a die to see possible combinations, what numbers would come out. Another example would be all the 52 cards of a deck of cards of a bridge. Bridge is a game, card game. There are 52 cards in a deck of cards. All of that 52 cards comprises the collection of all possible outcomes if you play a deck of cards. Now, visualizing events, because events is actually an idea, but we can visualize events using a contingency table like this, where we enter, for example, if we talk about cards with 52 cards, that would be the sample space, all the possible outcomes of a game of card. 52 ang sample space niya. But we know that there would be 26 of those 52 cards would be black, and the other 26 would be red cards. And if we talk about aces, mga alas, there are only 2 black aces, and 24 out of that 26 black cards, there are 22 black aces and 24 cards that are not aces. Similarly, for the red cards, the 26 red cards, there are 2 aces, 2 red aces, and the other 24 red cards are not aces. In all, there are 48 cards that are not aces, and there are 4 cards that are aces, for a total of 54. Now that's visualizing events, particularly a deck of cards. Events, if you play cards using a contingency table. We can also visualize events using tree diagrams. Again, using a full deck of cards, which are 52 full deck of cards, which again is the sample space, the total combination of all cards. And out of that, the same with the contingency table, there are 26 black cards and 26 red cards. It's all the same idea, only using different way of visualizing the event. Now let's define an event of interest. What is an event of interest? Using a scenario, particular scenario, a scenario with KPMG Accounting. It's an accounting firm, company. The KPMG accounting firm is interested in the sample space for an audit experiment in which the outcome of interest is the audit's completion status. Remember, completion status. The sample space is the list of all possible outcomes from the experiment. That's true to all. The accounting firm is also interested in specifying the outcomes that make up an event of interest. This can be done using the following steps. Step 1. Define the experiment. What is the experiment all about? The experiment consists of two randomly chosen audits. Audits, we know audits is a process of checking an accounting report as to its accuracy, how accurate the accounting report was. And auditors are also accountants. They check whether or not an accounting report was accurate or not. Now, step 2, list the outcomes associated with one trial of the experiment. For clarity, we list down possible outcomes of a single trial of the experiment. For a single audit, the following completion status possibilities exist. Kining tulo. Audit is done early, audit done on time, audit is done late. Kini siyang tulo ang possible status. Early, on time, late. Tutulo. Then step 3, define the sample space. The sample space, the total possible combination. For two audits or two trials, we define the sample space as follows. Here we see there are event 1 to event 9, and these are all the possible combinations of two audits. For audit 1 and audit 2, based on these three possible outcomes of a single audit, we can see that there can be these possible combinations. Early for audit 1 and audit 2, early audit for 1 and early audit for 2, early audit for 1, on-time audit for 2, early audit for 1 and late audit for 2. And then for on time, see, audit 1 is on time, and it can be combined with audit 2, early, on time, and on time, and late, early, late, on time, and late. So that's why there are 9 possible combinations. Step 4, define the event of interest. The event of interest, at least one audit is completed late, is composed of all the outcomes in which one or more audits are late. This event E is based on this na isa sa ilang duha is late. This would be 1 and 2, 3, 4, 5, and this one 5. At least one of them. Pwede sila nagdungan nga late, pero at least one of them. So that space is E3, E3, A is 6, E7, A8, and E9. So there are 5 ways in which one or more audits are completed late. So that's what an event of interest is defined. Now, events are also can be there are elementary events which are defined as an outcome from sample space with one characteristic, isa lang characteristic, and denoted as letter E. Example, a red card from a deck of cards. Of course, we know there are 26 different red cards in a deck of cards. One of those can be an elementary event. If we take a card from the deck, one of those that can be a red card. The event may also involve not necessarily only one, but it may also involve 2 or more outcomes simultaneously. And in this case, these are indicated with a big letter E. Example would be an ace that is also read from a deck of cards. An ace that is also read from a deck of cards. Kung ganiya kay red card man lang, basta red card, hindi siya kay duha ang iyang event, duha ang iyang kondisyon. Duha, red o ace. Ang card must be red, and at the same time the card must be red. There are 2 events, the color and whether it is ace or not. Now, further example of elementary events. Here, an automobile consultant, kulang N. An automobile consultant records fuel type and vehicle type for a sample of vehicles. And these are what are in the records. 2 fuel types, which I think is familiar to us. Gasoline. Fuel types are gasoline and diesel. Baluta diesel karon is mas mahal. Dati, before sa Ukraine war, gasoline, diesel was cheaper than gasoline. But now, diesel is more expensive than gasoline since Russia invaded Ukraine. Now another on the record is the vehicle type, which there are three vehicle types: truck, car, and SUV. SUV, in case you do not know, SUV stands for Sports Utility Vehicle, SUV. Car is the regular family car. Think it's a sedan. A truck is a vehicle that is used for loading, hauling things, usually open at the back para daghan makarga. So, visualizing them um, here, fuel types, two fuel types, vehicles that uses certain fuel types, gasoline and diesel. And for gasoline, there is a truck, there is a car, there is an SUV. And the same with diesel, there are vehicles that uses diesel fuel, that is a truck, that is a car, and also that is an SUV. So here we have 6 possible elementary events. E1 is defined as uh, a vehicle that uses gasoline, which is a truck at the same time. E2 is defined as a vehicle that uses gasoline and is a car. E3 is a vehicle that uses gasoline and that is an SUV. E4 is a vehicle that uses diesel and is a truck. E5 is a diesel that is a car, and E6 is a diesel vehicle that is an SUV. Now, there are more concepts on probability. More concepts. There's also concept of mutually exclusive events. Events man to atong gi-discuss ganiya, elementary events. Elementary events, basic events. Now more probability concepts, mutually exclusive events. So there are events that are mutually exclusive. That is, events that cannot happen together. If E1 occurs, then E2 cannot occur because they are exclusive. Murani sila og kanang magkalaban ba nga dili pwede mag-abot, kay kung mag-abot sila gubot. Kung naa si E1, dili pwede nga naa si E2 and vice versa. Therefore, they have no E1 and E2 have no common elements. Wala sila commonality. In the case of a deck of cards where there are the cards are divided into black cards and red cards, they have no commonality. A card, because a card cannot be black and red at the same time. Dili pwede. Another concept about probability is the independent and dependent events. Independent events, these are occurrence where one does not influence the probability occurrence of the other. Independent sila. Whereas for dependent events, an occurrence of one affects the probability of the other. Now let's contrast and compare independent versus dependent events. For independent events, say E1 is the heads on one flip of pair coin. Coin ba ka ng kwarta nga coins? Head. E2 heads on second flip of same coin. Same first ang E1 is the first flip, first ka primero nga giitsag patuyok ang coin. Ang E2 is ikaduha. Result of the second flip does not depend on the result of the first flip. In this example, dependent events is different because one affects the other. For example, if event 1 is a rain forecasted on the news, for example, if you listen to the news forecast, you are likely, if there's a rain forecasted, you are likely to bring umbrella to work or to school if there is a rain forecasted, right? So the second event is dependent on the other. Your bringing an umbrella to school is dependent on the forecast. If the forecast was no rain, so no umbrella. But if the forecast says it will rain, the probability is that you'll take along with you your umbrella. Here, the probability of the second event is affected by the occurrence of the first event. Now let's calculate probability. The probability are numbers, percentages of possibility that an event is going to happen. Now there are three different ways of calculating probability. First is the classical probability assessment. Classical, itong usual na ginagamit. And this is defined as probability of E sub I equals the number of ways E sub I can occur, or the sample space here, the sample space, or sample interest or event of interest over the total number of elementary events. The second way to assess, to calculate probability is the relative frequency of occurrence. Relative frequency of occurrence. I'm sure you are by now familiar with the term relative frequency from our previous laboratory exercises. Here, the concept is expanded to relative frequency of occurrence. The relative frequency of occurrence or is given by this formula. Relative frequency of E sub I is equals the number of times E sub I occurs over N, or this the total, this is the sample space. The third method of calculating probability is called subjective probability assessment. This is an opinion or judgment by a decision maker about the likelihood of an event. This can also be called as an expert probability assessment. Someone who is an expert or who know more about, say, rain forecasting, and he look at the sky and determine by the type of clouds present and by what he can see in the sky, and he or she would determine, he would assess the probability of getting rain. Subjective probability assessment. Now let's illustrate the classical probability assessment. The managers at using a realistic scenario. The managers at Galaxy Furniture plan to hold a special promotion over Labor Weekend. Labor Weekend. Each customer making a purchase exceeding $100 will qualify to select an envelope from a large drum. Large drum. This drum would be what we call a tambulo. Inside the envelope are coupons for percentage discounts off the purchase total. At the beginning of the weekend, there were 500 coupons. This is the total number of coupons that is provided. 400 of these were for a 10% discount, 50 were for 20%, 45 were for 30%, and 5 were for 50%. Customers were interested in determining the probability of getting a particular discount amount. The probabilities can be determined using classical assessment with the following steps. Step 1. Define the experiment. Experiment is an envelope. An envelope is selected from a large drum, a tambulo. Step 2. Determine whether the possible outcomes are equally likely. O random ba gid siya. In this case, the envelopes with the different discount amounts are unmarked from the outside and are thoroughly mixed in the drum. Thus, any one envelope has the same probability of being selected as any other envelope. The outcomes are equally likely. So that's random. Step 3. Determine the total number of outcomes. There are 500 envelopes in the drum. Step 4. Define the event of interest. We might be interested in assessing the probability that the first customer will get a 20% discount. So we want, for example, here we want to know the probability ng first customer will get 25%. What's the probability? Step 5. Determine the number of outcomes associated with the event of interest. The event of interest is 20% discount. There are 50 coupons with a discount of 20% marked on them. 50, and that's out of 500. Step 6. Compute the classical probability using equation 4.1. That was the equation given previously. It's the same, this one, where probability E sub I equals the number of ways E sub I can occur over the total number of possible outcomes, where here we're interested in the probability of getting a 20% discount, which in the whole sample space there are 50 out of the whole sample space in 500 coupons. There are 50 marked 20%. So 50 divided by 500 is 10% or 0.1. Note, after the first customer selects an envelope from the drum, the probability that the next customer will get a particular discount will change because the values in the denominator and possibly the numerator will change. Yes, for the next customer, kung nakuhaan na isa, the denominator will now become 499, dili na 500. So mag-change ni sila every time nga na nakuha na draw. Now, that was the classical probability assessment. Now, let's go to the relative frequency assessment. The relative frequency assessment approach is based on actual observations. Relative frequency is equal a probability of E sub I equals the number of times E sub I can occur over N, where the E sub I is the event of interest and N is the number of trials. Now let's illustrate this using a certain scenario here with the Hathaway Heating and Air Conditioning. It's a company. The sales manager at Hathaway Heating and Air Conditioning has recently developed the customer profile shown in Table 4.1. The profile is based on a random sample of 500 customers. As a promotion for the company, the sales manager plans to randomly select a customer once a month and perform a free service on the customer's system. What is the probability that the first customer selected is a residential customer? What is the probability that the first customer has a Hathaway heating system? These are the customer category, E1 and E2, commercial, residential. And E3 is heating systems, E4 is air conditioning systems. For E1 and E2, they are E1 and because these are we're looking at the intersection between the events E1 and E3. There are 55 commercial customers. These are businesses. Kina residential mga homes. For event 4, air conditioning systems, there are 45 commercial business establishments and there are 255 residential mga homes, mga na air conditioning. For a total of 300, for heating systems, a total of 200. And the total space is 500. Okay. To determine the probability that the customer selected is residential, we determine from table 4.1, is the same one, the number of residential customers and divide by the total number of customers, both residential and commercial. We then apply equation 4.2, which is 400, and residential is 400 over the total is 500. That's 80%. Thus, there is an 80% chance the customer selected will be a residential customer. The probability that the customer selected has a Hathaway heating system is determined by the ratio of the number of customers with heating systems to the number of total customers. Here, from the table, heating systems are, there are 200 of them that has heating systems. 200 over the total number of customers, which is 500. So 200 divided by 500, we have 40% chance that the randomly selected customer will have a Hathaway heating system. Okay, it's the same. Well, the sales manager hopes the customer selected is a residential customer with a Hathaway heating system because there are 145 customers in this category. The relative frequency method assesses the probability of this event occurring as follows. Probability tayang gi-hope na residential with a Hathaway heating system. Probability E2 residential, and E3 heating is 145 over 500, so equals 29%. There's 29% chance the customer selected will be a residential customer with a Hathaway heating system. Now, with all of those definitions and scenarios, examples, let's now define rules of probability. Rules of probability. Let's start with number 1, of course. Probability rule 1. It says for any event E sub I where the probability of E sub I is greater or equal to 0 and is less than or equal to 1 for all iteration. That's 4.3. Now, possible values and the summation of possible values. If we are certain about the outcome of an event, we will assign the event a probability of 0 or 1, where P of E sub I equals 0 indicates the event E sub I will not occur, and P of E sub I equals 1 means that E sub I will definitely occur. If we are uncertain about the result of an experiment, we measure this uncertainty by assigning a probability between 0 and 1. Probability rule 1 shows that the probability of an event occurring is always between 0 and 1. Probability of an event occurring is always between 0 and 1, not outside from that range. Rules of probability number 2. Summation of summation, di ba, kini siya sigma is summation of I from where that started from 1 up to k, summation of all the probabilities of small e sub I. If you total them all, is always 1, where k kana siya equals the number of outcomes in the sample, and small letter e sub I kana siya is the ith outcome. That's 4.4. All possible outcomes associated with an experiment form the sample space. Therefore, the sum of the probabilities of all possible outcomes is 1, as shown by probability rule number 2. Simple? Simple ra ang rule 1 and 2. Now, rule number 3. Addition rule for individual outcomes. The probability of an event E sub I is equal to the sum of the probabilities of the individual outcomes forming E sub I. For example, if E sub I is equal or is the set E sub 1, E sub 2, E sub 3, then the probability of E sub I is equal to P probability of E sub 1 plus probability of E sub 2 plus probability of E sub 3, and that's 4.5. Addition rule for individual outcomes says that if a single event is composed of 2 or more individual outcomes, then the probability of the event is found by summing, add the probabilities of the individual outcomes. This is illustrated by probability rule 3. Now, let's illustrate using a scenario. Edwards Cinemas. May cinema karon, no? Nasa Robinsons, I think, o sa SM. Is considering opening a 20-screen complex in Lansing, Michigan. This is in the US. And has recently performed a resident survey as part of its decision-making process. One question of particular interest is how many movies a person goes to during 1 month. Table 4.2 shows the results of the survey for this question. The sample space for the experiment for each respondent is, here is SS sample space, is a set of E sub 1, E sub 2 to E sub 4, where the possible outcomes are E sub 1 at least 10 movies, E sub 2 is 3 to 9 movies, E sub 3 is 1 to 2 movies, and E sub 4 0 movies. Dili mo tanaw og salida. Here is the table. At least 10, that means 10 or more. There were 400 respondents, which is 8% of the survey. 3 to 9 is 1,400, which is 38%, and 1 to 2 is true to 1,500 respondents, which is 30%, and respondents who does not go to any movie, there are quite a few of them, quite many of them, 1,200, which is 24%, almost 1/4. The total sample space is 5,000. Now, assume we are interested in the event respondent demand attends 1 to 9 movies per month. Kini siya. Kini siya ang pinakadako percentage, 38% of all the groups. Here, E is the respondent that attends 1 to 9 movies a month. The outcomes that make up E are E2, a set of E2 and E3. E2 and E3. One to 9, that is composed of two class intervals. We can find the probability of E by using probability rule 3, which is equation 4.5 as follows. 30.38 0.38 plus 0.3 equals 68%. 68%. Now, there's another concept, complement rule. Closely connected with probability rules 1 and 2 is the complement of an event. The complement of an event is represented by E bar. E nga na ay dash sa ibabaw. Kani siya. The complement rule is a corollary to probability rules 1 and 2, or addition siya, expansion, extension. Complement rule, that is, the probability of the complement of an event E is 1 minus the probability of event E. here illustrated. The complement of this scenario is this one. The complement or the inverse. Now, rule number 4. Rule number 4. Hapit na tamo man. Kay rule number 4 man ta ko to bining part 1. If E1 and E2 are not mutually exclusive, then probability rule number 4 states that addition rule for any two events E1 and E2 is like this. Probability of E1 or E2 equals probability of E1 plus probability of E2 minus probability of E1 and E2, which is visually shown like this. It's a union where the union kini siyang common ang E1 and E2 kini siya is subtracted from this union. Now, here's a scenario with a business application. Continued from Edwards Cinemas. Suppose the people who conducted the survey for Edwards Cinemas also asked questions about the respondents' ages. The company's managers consider age important in deciding on location because its theaters do better in areas with a younger population base. Table 4.3 shows the breakdown of the sample by age group and by the number of times a respondent goes to a movie per month. Table 4.3 shows that there are 7 events defined. 7 events defined. E1, E2, E3, E4, E5, E6, E7. 7 events. For instance, E1 is the event that respondent attend 10 or more movies per month. This event is composed of 3 individual outcomes associated with the 3 age categories. Isa nga event na tulo ka other possibilities, which are E1, E2, kana siya E nga gamay, siya E nga dako, E nga dako, E nga dako, E nga gamay. Notice class ang E, big letter E, more or less they are the class intervals, whereas the E nga gamay, these are the sample. Okay. Table 4.4 shows the relative frequencies for the data in table 4.3. These values are the probabilities of the events and outcomes. Suppose we wish to find the probability of E4 or 0 movies per month or E6 being in the 30 to 50 age group. That is P probability of E4 or E6. What is the probability? To find this probability, we must use probability rule 4. Table 4.5 shows the relative frequencies with events of interest not shaded. The overlap corresponds to the joint occurrence or intersection of attending zero movies and being in the 30 to 50 age group. Kani siya. Kani siya. Ay, kani o kana. Kana o kani. Intersection is kani. The probability of the outcomes in the overlap is represented by P or probability of E4 and E6 and must be subtracted. This is done to avoid double counting the probabilities of the outcomes that are both in E4 and E6 when calculating the P E4 or E6. Thus, the value is 56%. Therefore, the probability that a respondent will either be in the 30 to 50 age group or attend zero movies during a month is 56%. 56%. What is the probability a respondent will go to 1 to 2 movies or be in the over 50 age group? Again, we can use rule 4, and that is based on this table. It is 40%. 40%. Okay, that's the end of rule 4 class. Next lecture will continue with rules of probability number 5. Don't forget to read through, and because we will be having a quiz on this next week starting Wednesday. Quiz class, don't forget. Quiz, face to face quiz. Bye for now.